Hello and welcome everyone. Today we will discuss about the state of stress. How are the state of stresses, that is sigma 1, sigma 2 and sigma 3, are represented. Before starting the lecture, one thing you must know that in structural geology we take compression as positive and tension as negative. In engineering geology it is opposite, where we take compression as negative and tension as positive, but for structural geology we take positive as compression and negative as tension. Also, all the values which are taken on the right side are positive and those on the left side are negative. So let's begin with our first state of stress, that is lithostatic or hydrostatic. Lithostatic or hydrostatic pressure. In this case, we know that in this case the thing remains constant, the object remains constant. Why? Because the direction from all sides are equal. So in case of lithostatic pressure, sigma 1 will be equal to sigma 2 will be equal to sigma 3. Alright. And in Mohs circle we represent hydrostatic pressure or lithostatic pressure as a point on a normal stress component. This is normal stress, this is shear stress. So this was our first state of stress. Then we have uniaxial stresses. These are of two types. Number one is uniaxial compressional and second one is uniaxial tension. So in this case, what I told you earlier, that we take any compressional component as positive and tensional component as negative. So in case of uniaxial compression, see, the word itself is uniaxial. That means there is only one force, tectonic force is being applied. So in this case, if it is compression is what? You see, sigma 1 component is always compressional, right? So sigma 1 will be greatest here. Sigma 1 will be greatest there, which is greater than 0, and other components, which is sigma 1 and sigma 2 and sigma 3, these two will be 0. So in Mohs circle we will represent uniaxial compression in such a way that sigma 1 is greater than 0. This origin is our 0 value, so this thing is our sigma 2 and sigma 3, and this is our sigma 1. Sigma 1, this is our uniaxial compressional circle for Mohs diagram. It is a circle, but cursor is, I cannot draw properly with mouse cursor, so it is a circle, assume that. Then we have uniaxial tensional. Tensional is always a tension, negative. So in case of, if we want to represent it in a Mohs circle, its representation is such that sigma 3 will be on the negative side because it is tensional, and sigma 2 and sigma 3 will be what? 0. So sigma 1 is less than 0. Sigma 3 is less than 0, whereas sigma 1 and sigma 2 is equals to 0. So this is 0, this is, assume if we take on an integer scale, number scale, if we take, this is sigma plus 1, this is minus 1, just for assumption, okay, but don't take as if these are the only values. We can plot this sigma 3 and sigma 1. So according to the criteria of uniaxial tension, sigma 3 is always less than 0 and sigma 1 and sigma 2 are equal to 0. So this is how a uniaxial tension will look like. Then we have biaxial stresses. In biaxial stresses, from the name itself, it is something that the values must be on both the sides of compression and tension. So biaxial stress is what? Sigma 2 will be 0 and sigma 1 will be greater than 0, but sigma 3 will be less than 0. So as earlier we said that assume it to be plus 1, this is minus 1. Sigma 1 is greater than 0, suppose this is sigma 1, and sigma 3 is less than 0, it is somewhere here, you say, and sigma 2 is 0, right? So for positive compressional side, the circle will be here, and for negative one, the circle will be here. Alright, now here comes the general triaxial stress. Triaxial stress, that means all the sigma 1, sigma 2 and sigma 3 components. So in general triaxial stress, what we have? Triaxial can be both general tensional triaxial stress and compressional triaxial stress. So in both the cases, remember always sigma 1 will be greater than sigma 2 will be greater than sigma 3, but they are not equals to 0, right? Say for example, let's take tensional first. So this is our Mohs circle, this is a straight line, alright? So this is 0, minus 1, minus 2, and this is minus 3. So in this case, sigma 1 is here, sigma 2 is here, and sigma 3, this one let's take. So we see that this is sigma 1, this is sigma 2, and this is sigma 3. So it is clearly seen in the diagram that sigma 1 is greater than sigma 2 is greater than sigma 3, but they are not equals to 0, and they are on the tensional side, and they are tensional triaxial stress. Now let's see the example for compressional. Let it be 1, 2 and 3. This is 0. So the sigma 1 is here, sigma 1 is the greatest, this one, then sigma 2 here, sigma 2, and this number 1 is sigma 3. So again sigma 1 is greater than sigma 2 is greater than sigma 3, but not equals to 0. That's it. It was very simple. I hope you understood. Thank you.